Hello and welcome to the presentation Where the Tule Elk Roam, the Impacts of Highways and Fences on Tule Elk Home Range and Movement. This work is derived from my master's dissertation at California State University, Fresno, in collaboration with Kristen Langner from the California Department of Fish and Wildlife. Tule elk are a subspecies of elk endemic to California. They're uniquely adapted to arid, open landscapes and are a bit smaller than Roosevelt and Rocky Mountain elk. This is their historic range, but due to near extinction and urbanization, Tule elk inhabit just a small portion of that historic range, as you can see here. Now, California's landscapes have become more and more fragmented over time, and there are many potential ramifications of this. The questions that I'll be focusing on here are: 1, how do highways affect Tule elk home range? And 2, how do barriers affect Tule elk movement? The data for this research is from a GPS radio collar study carried out by CDFW. The elk in this study were located mainly around the San Luis Reservoir, located here on this map. Let me zoom out to show you. Here's California, and zoom in to the study site here. So most of the elk are sort of in this blue area. Now the GPS radio collars collected location data every 5 hours for about 3 years, and I used the location data to construct home ranges and to analyze the effects of different barriers on elk movements. To try to answer question 1, how do highways affect Tule elk movement, I calculated several metrics for home range, including area, edge length, and the edge to area ratio of the 95% home range, and the 50% core use areas within the entire home range. I then used a discriminant analysis to test whether these metrics could be used to differentiate between home ranges within 100 meters of a highway or adjacent to a highway versus home ranges that were further away, so not adjacent to a highway. To try to answer question 2, how do barriers affect Tule elk movement? I mapped out the Tule elk location points and connected the dots to trace their movements, as you can see on this map here. I then searched for potential barriers such as roads and fences using Google Earth to see whether they coincided with any movement patterns. Here you can see what home ranges look like. This map just shows 2 individuals, one right here, one right here. And this map shows many home ranges stacked on top of one another. And as you can see, there's a lot of overlap and shared space here. So for question 1, how do highways affect home ranges? So the discriminant analysis was able to discern whether or not a home range was within 100 meters of a highway about 86% of the time when using 4 of the home range metrics. So the edge lengths of the 50% and 95% home range and the edge to area ratios for the 50% and 95% home range. In general, home ranges adjacent to highways had shorter edge lengths or perimeters. They also had higher edge to area ratios. Now, question 2, how do barriers affect movement? I broke the study area up into 8 grid sections. I think you can see that up here. 1, 2, 3, 4, 5, 6, 7, 8. Let me go back down. I just have one of the grid sections here. So each gray dot represents an elk location point, and this map includes all of the individuals and all of their location points. You can immediately see areas such as this one right here, where point density shifts very abruptly. These areas almost always corresponded with a landscape feature that was visible in Google Earth. For example, this right here is a barbed wire fence, and this is a particularly steep section of the San Luis Reservoir Dam. And you can look at the other objects in the legend if you would like. Now on this map, and this is the same area, I connected the dots for each individual elk and labeled them with different colors. So each color is a different elk. You can see that some elk really seem to avoid that fence right here, but others, this one right here, this pink one, if you can see that, this actually was crossing back and forth rather frequently. And now back to question 1. In general, there was evidence that the highway constrained elk home ranges quite a bit. Elk near the highway had shorter perimeters and higher edge-to-area ratios, indicating that their home ranges were, in effect, forced into a higher proportion of small areas. And for question 2, in general, the highway was an extreme barrier to movement. Elk do occasionally cross, but this is rather uncommon compared to the number of times elk come near the highway. And so it's important to note that the highways in this study were flanked by barbed wire fences on both sides, and it seems likely that these fences greatly inhibit elk movement along the highway and in other areas as well, as you saw earlier right here, this barbed wire fence, for example. So roads and fences can have tangible effects on wildlife, including large mammal, home ranges, and movement. However, there really seems to be a lack of public data available on fences and other potential landscape barriers. And yet it is critical to consider these effects when studying or trying to promote habitat connectivity in a developing landscape, such as in California. Thanks for listening. Feel free to scroll through this presentation on your own, and have a good day.